Hey guys, today we got logarithms and logarithmic functions, part 2, second part of what we did yesterday. Let's go. Okay, it says evaluate log 8 and natural log 0.3 using a calculator around answer 3 decimal places. Okay, now this one absolutely is just taking your calculator, finding your log button, which is a couple of buttons up from your on button on that left-hand column right there, and just hitting log. Now, your calculator knows base 10 and base E, so I'm getting mine out right now. Sorry about that. So I'm just punching log 8. When I hit log 8, I'm getting 0.903 to 3 decimal places, and then it says ln, or natural log, of 0.3. Same thing. The natural log button is directly underneath your log button, hitting 0.3. I'm getting negative 1.2. Now, the reason I'm getting negative 1.2, a negative number, it should be 4 right there, sorry, is because that's a decimal. Remember, that base is E, so E is actually getting smaller. So I'm going to flip it to make it smaller. And remember, the negative exponent is what flips it. So I hope that makes a little bit of sense. We'll talk about that more tomorrow. All right, so simplify these. If the log in your exponent is based the same as the base here, they basically, remember, the log is the inverse of an exponent, so they really just cancel and you get 4. That's all you do there. This one says 5 to some power is 25 to the x power. Okay, so I'm going to write that out. 5 to some power, don't know what it is, equals 25 to the x power. So what I'm going to do is basically make both those bases the same, and go like 5 to some power. 25 is really 5 squared, so I'm going to do 5 squared to the x. So here's what I got. I got 5 to some power is 5 to the 2x. So now that the bases are the same, that also means the exponents must be the same. So what power would you raise 5 to get 25 to the x? The 2x power. Okay, it's not going to be just one number there because your answer, remember, the answer to a log is the exponent. What exponent would you raise 5 to get that value right there? The 2x power. All right, find the inverse. Remember, x and y switch, get the y by itself. So I'm going to put the x over here, the y over here. Now, the way you get the exponent is you take a log both sides. So I'm going to do log, and whatever the base is on the right side, so I'm going to do log base 6x equals log base 6 to the y power. Now, on the right-hand side, 6 to what power? 6 to the y. Y is. Okay, basically, these almost cancel, so you get y equals log base 6, which is your answer. Don't forget we write our answer with the f negative 1. But again, 6 to what power? 6 to the y? The y power. That's why I did base 6 there. Made it much easier. Okay, another one. Find the inverse. So I'm going to switch the x and y's, put the x over here, put the y in here. All right, now I got to get that y by itself. So I'm just going to do the log. Remember, that's base e. So I'm going to go e to that power equals that. So e to the x equals y plus 3. And some people are like, where did the natural log go? Where did the ln go? I did the natural log. Remember, it means e to the x equals that. So to get the y by itself, I'm just going to subtract the 3. So I get my f negative 1, e to the x minus 3. And there's your inverse. Okay, graphing logs. Now, the graph of a log, as long as your base is bigger than 1, you got base b right here, bigger than 1, they're exact opposites of what the exponential graph was, exponential growth and decay were. If you remember we did exponential growth, the x-axis was the asymptote. With logs, the y-axis is going to be the asymptote. So we look at these graphs down here. That blue graph right here is what we did last time when we did exponential growth. X-axis is an asymptote. It grows like that. We talked about the money doing that. The red one is the log graph. And remember, they're inverses of each other, so that means they're reflected on that line y equals x, like we talked about. They're reflections of each other. So you can tell the difference is now the y-axis is the asymptote. Instead of going through 0, 1, it goes through 1, 0. Then the points switch, and it goes like that. Now, if b is less than 1, or your base is less than 1, it's going to go the other direction. It's still going to pass through 1, 0, but it's going to get closer to the y-axis going that way and go down that direction. Again, it's a reflection over the line y equals x, as always. The domain is going to be everything greater than 0, and the range is going to be all reals because it's going up and down forever. Now, those were the exact opposite last week. Like when we did the exponential growth and decay, the domain was all reals and the range was y is greater than 0 usually. So they also just flip-flop because they're inverses. X and y switched. Domain is x, range is y. They just switched. All right, let me show you one here, graph f of x equals log 3. Now here's what I know. There's no shift there at all, which means the y-axis, you don't have to do this, but I'm going to draw it anyway. The y-axis is an asymptote. It's going to pass through the point 1, 0. Now I'm going to look for 2 points here. What I want you to do is whatever that base is, plug in that number right there. So I'm plugging in log base 3, 3, which is saying 3 to what power is 3? Well, hello, the first power. So log 3, 3 is 1, just like log 4, 4 is 1. Log 5, 5 is 1. Throw 1. So that means I plugged in 3 for the x, and I got 1 for y. So my second point's 3, 1. Now I can connect the dots, and there's my log graph. Okay, that's simple. Again, I'll be looking for 2 points on Friday. Hopefully that makes a lot of sense. We'll work on all that stuff tomorrow. It's quite a bit, actually. Working on that tomorrow. Can't wait to see you.